Hi, I'm Yusuf. It is the third example of 4-axis simultaneous models. We will machine it. We will make first roughing and second finishing. We will make roughing with using this curve, this helix. But it must be on the surface of the on the surface. So we will project it. Project curve. We choose it. We project it toward line. We must create a curve for it. No, we have created it actually. Okay, here. Project curve. Curve the projects. Select object. Select line and we switch to static wireframe and choose the curve. Click OK. We have that curve, but we must extend the helix because we know that the tool must engage the surface from outer of the face. So menu, edit, curve length. We choose it. For example, 9 and 9. Replace. Okay. Then we extended the curves. Okay. We choose the blank in this workpiece and we choose the parts under this blank. Okay, we create operation. We choose mill multi-axis, variable contour, ball mill 10, curve point, click OK. We will not use workpiece. We will choose the curve here. Okay, curve point is here. Okay. Okay, let's click generate and see what happens. What happens? Why? Okay, insert operation, variable contour, curve point, select the curve and specify parts, curve and choose the curve, click OK and generate. No, pardon. We didn't choose this tool axis and towards away from line. We click OK and we click generate. Okay. Now we have one single toolpath that on the curve, created on the curve, but we must multiply that. So cutting by methods, multiple passes, 6 mm, multi-depth cuts, and dot 3. And we click generate. But I can see that these moves aren't in 4-axis. Why? Because non-cutting moves transfer rapid must be cylinder. Vector is that, and radius is 55. Between regions, clearance tool axis, departure, clearance tool axis, click OK, and click generate. And now these air moves are in 4-axis. Okay, but we forgot something. We forgot to leave a stock .2, and now we can see that stock from here. Okay, now we will make finishing. We can choose workpiece when finishing, insert operation, variable contour, surface area, drive geometry. We choose the drive geometry, cut direction, and it must be this zigzag number 50, and it mustn't be 10 to, it must be on, so tool should start from here, tolerance and display. Okay, we click OK. We choose away from line again, but we do not use toward line. It stays tool axis, and I click generate. Okay. As you can see, tool moves okay. I have shown it, but let me repeat it again. With these standard parameters, we will not have a good surface, because as you can see, this between these 2 points, it is G1. It must be better, so we must change the intol outtol and more to 1 millimeter. With this we can have good surface, but I will not do it because the calculating time will extend too much. Okay, the next thing is machining this half spheres. First we draw line from one quadrant to another. It may not be just 90 degrees actually. Okay, point on face, and dot 5. Oh, it's problem. Okay, that's not important. I'll look like that, and point on face, and click here. Okay. Okay, create operation. I will not make a simultaneous operation. I will use mill contour, streamline. I choose it and choose the point. Helical. Specify cut direction. Is tolerance and preview. Okay, it's not important. I'll use tool axis like specify vector and 2 points. Okay, and I change the number to scallop .335. I will change the clearance option to automatic plane and 40. It is very big tool. I'll use 6mm ball mill, and I will reduce the scallop. Okay, I don't need it because it's a scallop. Okay. It makes helical move, and it makes one engage and one retract. You can machine these half spheres like this. Okay, it's all for this video. Thank you for watching. If you have questions, please ask me on comments.